Hey guys, welcome back. So today we're going to talk about the chain rule, but before you get started with that, make sure you fully have all the rules so far on your derivatives completely memorized. Got to know when to do a product rule, when to do a quotient rule, okay? If you don't know those first and you don't know those really well, then the chain rule is really going to mess you up. So good luck, here we go. So for the first example, I want you to do this using a product rule, and then I'll show you the quicker way using the chain rule. So using a product rule, you'd have to first write it like a product. So just expand it, write it twice. And do your product rule. So hit pause and do that, and we'll check it in a minute. Okay, so I didn't simplify it yet. I just wrote the first step of the product rule. But hopefully you can see there's a quicker way than distributing it all and combining like terms. I'm going to just instead factor out the 3 from both. Both these groups have a 3. Or I'll just do it the way you probably did it. You probably distributed, okay, 9x minus 3, 9x minus 3, 18x minus 6. Okay, so that's the product rule. We should still get this same answer using the quotient rule. Okay, so hold on to that answer, and now let's do it. I don't know why I said quotient rule. I'll take it back. Now we'll get that same answer using the chain rule. Okay, so you're not going to fully understand this yet. It's going to take me a couple chances before you'll actually see how it works. But here's how the chain rule works, okay? So the derivative would be derivative of the outside, which is the exponent. So 2 times 1, power rule. Derivative of the outside, leave the inside the same, and subtract 1 like normal. But then, that's clearly not the same as this answer down here. Then you have to multiply by the derivative of the inside. Well, the derivative of the inside would be a 3, so I'll stick that out front, and I get 6 times 3x minus 1. And that's much faster than the product rule. So is that answer the same as the one we got using the product rule? Yes, if I factored out at 6, it would be. Okay, so now let's focus on the chain rule and when to do it. Okay, this is the fancy notation for chain rule. It looks crazy, but it's actually not so bad. You'll get used to it, and we use it all year. It's the basic computation of calculus for the whole year, so you have to know this for life. All right, so you use the chain rule when you have a function within another function, okay? In the case that we just did, the outside function was something squared, the square function. The inside was the 3x minus 1, okay? And what this says to do, to find the derivative, you do the derivative of the outside, that's what this says. Leave the inside the same, that's what this is. And multiply by the derivative of the inside. Okay, so derivative of the outside. Leave the inside the same, and multiply by the derivative of the inside. All right, so I'm going to do a couple of easy ones just to give you the feel for it, okay? Let's say the original function was something that you know pretty quickly, 3 sine of 5x, okay? Well, the outside part would be the sine, the inside part is 5x. So you have a function within a function. So the derivative, and you're just basically going to train yourself to do this automatically. The derivative would be the derivative of the outside, which is 3 cosine, leave the inside the same, times the derivative of the inside, and the derivative of the inside would be 5. So this is 15 cosine 5x. Okay, that's an easy breezy chain rule. So now let's do a couple more. We'll do some just like this, nice and easy, and then we'll step it up. Okay, so let's do another trig one. Let's say we have, negative 3 cosine of 2x squared plus 1. Yeah, there we go. All right, so derivative. Why don't you hit pause and see if you can do it on your own. So derivative of the outside would be the derivative of this piece. So 3 sine. Remember, when you write sine, change the sign. Leave the inside the same. Multiply by derivative of the inside. Derivative of the inside would be a 4x. And I usually just stick that out front next to the other coefficient. And then clean it up a little bit. multiply these guys together, 12x sine of 2x squared plus 1. Okay, chain rule. All right, now I'm going to bore you with a whole bunch of examples. If you think you can do this one on your own, why don't you give it a shot? Okay, hit pause, and then I'll work it out for you. Okay, derivative of the outside would be the exponent. Power rule. So it's 100. Leave the inside the same and subtract 1 from the exponent. Times the derivative of the inside, which is 3x squared. Stick that out front, and then just clean that up. 3 times 100 would be 300x squared. X cubed minus 1 to the 99th power. You certainly wouldn't want to have to do that one with a product rule because you'd have to multiply out 100 things. That would be ridiculous. Okay, so that's why the chain rule is so good. Next. Okay, see if you can try this one. It's pretty much the same as the last one, except the algebra, when you simplify it, is pretty ugly. Okay, first, hopefully you knew to rewrite the square root as a 1/2 power. And then you're just going to do a power rule, chain rule again. Same as the last one. It's just a little less pleasant to write it because of the square root. So power rule, 1/2, derivative of the outside. 1/2, leave the inside the same, subtract 1. And you get negative 1/2. Times, derivative of the inside. This one's going to be a little bit uglier, so I'll just write it on the back this time. It doesn't matter since it's multiplying. Derivative of the inside would be 3x squared plus 2. Now, if you could leave the answer like that, then that'd be no big deal. But that negative exponent has to go. So just move that piece to the bottom. And this 2 is already on the bottom. You don't want to write your final answers with fractions within fractions. Write one big fraction. So you got to get used to how those answers are going to look if this was a multiple choice question. So this guy's in the numerator. The 2 here is in the denominator. And this negative 1/2 power is going to move to the bottom and become a positive 1/2 power. But to be honest, they probably wouldn't leave it as a 1/2 power. They'd go back and rewrite it as a square root. There's your derivative. Hopefully you got that on your own. Okay, so this one you have choices. Clearly it has a division bar, so you could use a quotient rule. But this is so much faster if you can rewrite it as a chain rule. So again, you could do a quotient rule, but quicker and easier, and it comes up a lot, is going to be to visualize that this is some junk to the first power, move it up into the numerator and make it a negative 1 power. So when you write this problem down, don't even write it the way it is. The 3 is in the numerator, move the 2x minus 5 to the top and make it a negative 1 power. Now this is an easy power rule, chain rule again. So the derivative is the derivative of the outside, negative 3. Leave the inside the same. Subtract 1, and you get negative 2. But don't forget, because it's what everybody forgets, multiply times the derivative of the inside. Say it every time you do the problem. Say times the derivative of the inside in your head. So times 2, which since it's just one number, I'll squeeze that out front. Final answer would be negative 6. Move this negative exponent to the bottom over 2x minus 5 squared. That's your final answer. Hopefully you got that right. Okay, next one. This one I chose because there's one like this in your homework, and you could make this one really difficult and a pain in the butt, or you could make this one pretty easy. So, if you tried to do a power rule, chain rule, the derivative of the inside the way it is, oops, sorry about that, go back. The derivative of the inside the way it is would be just like that last problem, and I don't think that would be that easy. But if you notice when you square something that you just square the top and square the bottom, then you could rewrite this problem a lot easier. Here's what I mean. If I had 4/5 squared, that's just 4/5 times 4/5. And it basically just means you square the top and square the bottom, 16 over 25. Well, that is how we could simplify this problem before we even begin. So I'm going to rewrite f of x as 3 squared, which is 9, over x plus 5 squared and just leave it x plus 5 squared. That's the quickest way to do this problem. Now, I didn't do any calculus yet. All I did was rewrite it using algebra. But now you can do the problem just like we did the last one. Move the square to the top and make it negative. And now you have a power rule chain rule. Okay? Now, be careful with your notation. I noticed on the last test that a lot of you aren't writing what you're finding with each step of the way. And if you don't write that you're finding the derivative, then the AP graders don't give you credit for just stuff that you don't know what it is. Also, it helps you know whether or not you remember to get the derivative, because you do a lot of math before you even do the calculus. So practice writing your notation each step of the way. So now I'm going to do my power rule. Negative 18, leave the inside the same. Subtract 1, you get negative 3, times the derivative of the inside. Thankfully, the derivative of the inside is just a 1. So that's pretty much the answer, except I have to move the negative exponent back to the bottom. So x plus 5 cubed. Okay, so I tried to keep it gentle for the first day of the chain rule. I didn't do the crazy ones yet. So good luck on your homework. You got this. Bye.